निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
In this session, we will be learning chapter 12, areas related to circle, and we will be doing the solution for exercise 12.2. For the exercise 12.2 from NCERT textbook, the question number 1 is, find the area of a sector of a circle with radius 6 cm if the angle of the sector is 60 degree. That means in the question, we have to find the area of the sector. Whenever we are saying that area of the sector, it is a minor sector, let me remind you. So we have to find the area of the sector of that circle. The circle with the radius 6 cm and the central angle is given to us as 60 degrees. So we need to find the area of the sector, this area of the sector with central angle 60 degree and radius is 6 cm. So we know the formula for finding the area of a minor sector. So area of a sector is given by theta by 360 into pi r square. We know this formula for finding the area of a sector. Thus, just we need to substitute the value of theta and r and we can get the area of the sector. So this is 60 upon 360 into, we can take the value of pi to be 3.14 also, we can take the value of pi to be 22/7 also, whatever we want to take, we can take it. Unless and until it is not notified. Suppose we take 22/7 into, the radius is 6 into 6. Let us simplify it. 0, 6 and this 6 cancels. So this is 22 into 6, 132/7 centimeter square. So this is the required area of the sector for the given question number 1. Let's move on to question number 2. Find the area of the quadrant of a circle whose circumference is 22 cm. Find the area of the quadrant. Quadrant means 90 degree. We have learned in coordinate geometry last year in class 9 that the graph is divided into 4 parts and each part is called a quadrant. First quadrant, second quadrant means each part the angle is 90 degree. Here also in terms of circle, quadrant means theta is 90 degree. The central angle is 90 degree. And let us move on to the question once again. Find the area of the quadrant of a circle whose circumference is 22 centimeters. That means the circumference of the circle is given to us as 22 centimeters. So circumference is given to us as 22 centimeters. In order to find the area of the quadrant, that is sector with 90 degree central angle, we need two things. One is the central angle 90 degree and the second we need the radius as per the formula theta by 360 into pi r square. We need two things. One is theta and one is r. We have theta in the quadrant, that is 90 degree. We don't have r. We need to get that r from the next condition that is given in the question, that circumference is 22 centimeters. So when circumference is given as 22 centimeter for the circle, we know that the circumference of the circle is given by 2 pi r and this is equals to 22 centimeters. Substituting the value of pi, 2 into 22/7 into r is equals to 22. Then r is equals to 22 into 7/2 into 22 is cancelled. So r is equals to 7/2 centimeters. Now we have got radius to be 7/2 centimeter and we have theta is equals to 90 degree for the quadrant. Now we can find the area of the quadrant. There is area of quadrant. Quadrant means it's a sector with central angle 90 degrees. The area of quadrant is given by theta by 360 into 5r square. So here the theta is 90 degree. So 90 degree upon 360 degree into the value of pi is 22 by 7. And radius we have got as 7 by 2 centimeters. So this is 7 by 2 into 7 by 2. We will simplify and get it answer. This is 90. 7 cancels, and 2 11 into 7, 77 by 8 centimeter square. This is the final answer for the area of the quadrant of a circle whose circumference is 22 centimeters. Question number 3. The length of the minute hand of a clock is 14 centimeters. So we have a clock. Enter. This is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. We have a clock-like structure. The minute hand is of the length 14 centimeters. Find the area swept by the minute hand in 5 minutes. Suppose the minute hand is somewhere here. This is my minute hand. If you observe, we can say it is a circular shape and the length of the minute hand represents the radius of the circle. So you can take the length of the minute hand to be 14 centimeters as r. What will be the area swept in 5 minutes? In 5 minutes, this minute hand will move to the position 1. To the position 1. That means in 5 minutes it will move to 1. And area swept will be this one. This is my area that is swept by the minute hand in 5 minutes. Now when it moves from 12 to 1, covering 5 minutes, it sweeps the area. It forms a sector if you see. A sector with the angle unknown. What is the angle? This angle, what is the angle? Because in order to find the area of that sector, we need the central angle of the sector. Where is that angle? So the very first thing that we will have to find out is the central angle for the sector that is formed in moving the minute hand for 5 minutes, that is from 12 to the 1 position. Now, in general, in a clock, in any of the clock, if the minute hand would have started from here and it had moved this way 1, 2, 3, 4, 5, 6, 7, 8 and finally it had reached 12. That means it had covered 60 minutes. In 60 minutes, it reaches to its original position from where it has started. That means it had swept 360 degree angle in 60 minutes. That means if we, in a clock, if we want to say, we can say that 60 minutes represents 360 degree. So we can say that in a clock, 60 minutes represents 360 degree. That means 1 minute would represent 360 degree by 60, that is equal to 6 degrees. 1 minute means 6 degrees. In our question, the minute had moved for 5 minutes. So 1 minute 6 degrees. Then what is the angle swept by the minute hand in 5 minutes? So what is 5 minutes? Would represent 6 degree into 5, that is equal to 30 degree. That means the minute hand had moved from 12 position to 1 position, covering 5 minutes and giving us a central angle of 30 degree. If it would have been theta, then our theta is now 30 degrees. Now we need to find the area of the sector. We have been given with the radius, we have calculated the central angle. Now it's very easy to find the area of the sector using the formula. So we can say area swept by the minute hand in 5 minutes is equals to theta by 360 into pi r square, and the angle struck by the minute hand in 5 minutes was 30 degree that we have calculated. So substitute 30 degree by 360 degree into, take the value 22 by 7, the value of pi to be 22 by 7, and radius is given to us as 14 centimeter, that is the length of the minute hand. So this is written as 14 into 14. Simplifying and solving will get the area straight. So 0, 0 cancels, 3, 12, 7, 2, 2, 6, 2 3s and 2 11. So finally we get 11 into 14 by 3. This is 154 by 3 centimeter square. So finally we can say that the area swept by the minute hand in 5 minutes is 154 by 3 centimeter square. Fine. The question number 4 has been left for you for practice. We'll be moving on with question number 5. In a circle of radius 21 centimeter, an arc subtends an angle of 60 degree at the center. Find the length of the arc, that is bit 1. Bit 2, the area of the sector formed by the arc, and bit 3, area of the segment formed by the corresponding chord. So let us draw a figure for it. We are given with a circle of radius 21 centimeter. A circle with radius 21 centimeter and an arc subtends an angle of 60 degree at the center. Let us consider this arc. This is an arc that subtends an angle 60 degree at the center, and the radius is 21 centimeters. So arc is equal to 21 centimeters. We need to find the length of the arc, area of the sector, and the area of the segment formed by the corresponding chord. So let us solve bit 1 first. We need to find the length of the arc. The length of the arc, we are given the formula and we have written it in the earlier case also, that when we are saying arc, it is always a minor arc. But here it is clearly concerned that the arc is extending an angle of 60 degree, so it is naturally a minor arc. So length of the arc is given by theta by 360 into 2 pi r. We have theta 60 degree, we have radius 22 by 7, and we can take the value of pi to be 22 by 7. So let us take 60 degree, that is theta by 360 into 2 into pi, the value of pi 22 by 7, and the value of the radius to be 21 centimeter as it is given. Calculating and solving, we will be getting the length of the arc. 6, 7, 3s are 3, 2s are, and 2 cancels. This is 22 centimeters. So the length of the arc, which arc, what we are finding, this is the length of the arc that we are looking for. So length of the arc is 22 centimeters. Then bit 2. We need to find the area of the sector formed by the arc. That is, now we need to find this area of the whole sector formed by the arc. This is also very easy, and we know the formula for it. That is area of the sector formed is equal to theta by 360 into pi r square. So theta is 60 degree upon 360 degree into pi r square, the value of pi 22 by 7, and radius is 21, so this is 21 into 20. Simplify, we get the answer to the area of the sector. 6, 7, 3s are 3, 2s are 2, 11. So this is 11 into 21. And nothing left in the denominator. This is 231 centimeter. Bit 3. We will move on to the next bit. We need to find the area of the segment formed by the corresponding arc. And if you remember during our discussion, we have written a formula for area of the segment in such a way that we have told that area of the segment can be found out by subtracting area of a triangle from the area of a sector. Since there is no triangle, we will have to form a curve. And this is my segment that is required, whose area is to be found out. And this area of the segment can be area of the whole sector minus area of the triangle. Now for moving on to the triangle, we have also again discussed that if the central angle is 60 degree, then the triangle so formed is an equilateral triangle. Because this is radius, so this is equals to this, both are radius, and following the angle subproperty of triangles, making these triangles equal, each angle will be 60 degree, 60 degree, and 60 degree. So it forms an equilateral triangle. So directly we can say that area of the segment formed by the arc that is given to us is equal to area of sector minus area of the triangle, so formed by joining the 2 points as a chord. So area of the triangle, area of center we have found out, that is 231 centimeters square, and the triangle is an equilateral triangle by observation we can say. So area of the triangle is given by the formula root 3 by 4 r square here, because each side is r. Continuing this, we can say this is 231 minus root 3 by 4, and this is 21 square. This is 231 minus root 3 by 4 into 441 whole centimeter square. So this is the area of the segment that is required, formed by the arc that is given to us. If we need to move further, you can substitute the value of root under 3, 1.73, and then you can find the final answer in form of decimals. But we can keep them in this form also. Coming on to the next question. Question number 8. And 6 and 7 has been kept for your practice purpose. A horse is tied to a peg at one corner of a square-shaped grass field of side 15 meter by means of a 5 meter long rope. So suppose this is my square field. The side of a square field is given to us as 15 meters. Say we can write here somewhere 15 meters is a square field, and a horse is tied to a peg somewhere here with a rope of 5 meters. Let us consider this to be 5 meter long rope. Fine, bit one. The area swept by the back part of the field in which the horse can graze. How much area can the horse graze with a rope of 5 meter tied to it? Suppose this is a 5 meter long rope tied to it. Maximum the horse can move to 5 meter and it can graze this one. This area it can graze everywhere 5 meter, not more than 5 meter. It cannot move more than 5 meters. So it can graze in an area swept by it for a distance of 5 meters. If you observe it very clearly, it forms a sector with the central angle 90 degree, as it was a square. So the angle is 90 degree. It can graze those grasses present within a radius of 5 meter only. So we can find that part very easily. The first part is very easy. Bit one. Area of that part, area of the part, area of field that the horse can graze. The horse can graze. This is the area of the sector, and that is given by theta 360 into pi r square. Here theta is 90 degree because it is tied to the end of the square. By 360 degree, we need to take the value of pi to be 3.14 as it is mentioned in the question. So this is 3.14 into the radius is 5 meter only, because the horse can raise at a radius of 5 meter. only. This is 5 into 5. This is 90 4s, so you can write 25 into 3.14 by 4 multiplied and get the answer. $78.50 by 4. So this is 19.625 meters. This is the area that the horse can graze with a rope of 5 meters in his hands, in his neck. Second, page 2. The increase in the grazing area of the rope, grazing area, if the rope were 10 meters long, now instead of 5 meters long, now the rope has been extended to 10 meters. And you have to find that increase in area. Now suppose he has a 10 meter long rope, then it can graze somewhere this total area. Then what is the increase in area? The increase in area is previously it was able to graze this much area, and this part is its increased area which it can graze. This part is the increased area. Then how to calculate the increased area? The increased area can be calculated by the area of the sector with radius 10 meter minus the area it was previously grazing, and now the radius is 10 meters. So increased area it can graze. Now we will solve it into increased area to be grazed. Increased area to be grazed by the horse is area of sector with, we can consider R is equals to 10 meter minus area of the sector where R is equals to 5 meters. Area of sector with radius is equals to 10 meter can be written as 90 by 360 into pi r square, that is 3.14 into r square, now the radius is 10 into 10 minus area of the sector with radius 5 meters, and we have already calculated, we did not calculate once again, is minus 19.625 meters square. We have to solve this. 90, this is 4 and this is 314 by 4 minus 19.625, and this will be 7. And this is 34, 8. 78.5 minus 19.625, subtract it, somewhere 78.5 minus 19.625, this is 75.48, and 70 minus 9, 8, 58.875, this is 58.875 meters. This much area extra that horse can graze if the length of the rope has been changed from 5 meter to 10 meter. That means as soon as the rope length is increased, the area of graze increased. But the increased area is always given by the area of the sector with the increased radius minus area of the sector of the previous radius, and finally we get 58.875 meters square of extra area that the horse will graze. Next question. Question number 9. A brooch is made with silver wire in the form of a circle with diameter 35 millimeter. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors. So the silver wire is used to make a circular brooch, and the same wire is used to make 5 diameters also. D1, D2, D3, D4 and D5. These 5 diameters are also made up of that silver wire. We need to find it. And this 5 diameters divides the whole circle into 10 equal sectors. 10 equal sectors. We need to find first the total length of the wire required, and we need to the area of each sector of the root. Moving on with one by one, let us see the total length of the wire, silver wire that is used. Where we have used the silver wire? Let's look at the question very clearly. That the silver wire is used to make the circular part. That means it is used in the boundary of the circle. That means that is the circumference of the circle. And second, 5 diameters are also made up of the silver wires. So let us solve one by one. First one. Length of the silver wire required. Length of silver wire required is equals to whether we have used that we have to find out. That is, we have used in the circumference of the circle. Circumference of the circle plus 5 diameters. The circumference of the circle is 2 pi r and 5 diameters, that means plus 5b, we can write in short form. And the diameter of the circle is 35 millimeters. This was given to us. So this can be written as pi into d, because 2r is d plus 5. Here, if you want to take d common, you can take d common, or else you can directly substitute the values and solve also. And simplify it. Pi plus 5. B is anything given in the book. To take the value of pi, no, it's not given. So we can take any value of pi. So diameter is 35 mm. Let us take the value of pi to be 22 by 7 and plus 5. The whole answer will come in millimeters only, because the diameter was in millimeters. This is 35. Take the LCM. This is 7. This is 22 plus 35 millimeters. And this cancels 5. So this is 5 into 57. 285 millimeter length of wire is required to make that root in the shape of circle plus 5 diameters. Then bit 2, we need to find the area of each sector. How many sectors were there? There were 10 equal sectors. The total angle, we need to find the area of each sector. Suppose area of each sector. In order to find the area of the sector, we need the central angle for the sector. The total angle at the center was 360 degree, and 10 equal sectors have been made. So each central angle would be the 10th part of 360 degree. So we need to find first that central angle. So each central angle is equal to 360 degree by 10, because the total circle was divided into 10 equal sectors. So each central angle is 36 degrees. Now we can find the area very easy. The area of each sector is given by theta by 360 into pi r square, and theta is the central angle of the sector that we have calculated as 36 degrees. So this is 36 upon 360. The value of pi is 22 by 7, and radius, diameter is given to you as 35 millimeter. So the radius will be 35 by 2 millimeters. So you can write this is 35 by 2 into 35 by 2, and the whole answer will be in millimeters squares. Simplify and solving. Let's see. 36. This is 10, sir. 7, 5, sir, and 5, 2, sir, and 2 is 11. So this is 11 into 35 by 4. So this is 385 by 4. This is 76. Sorry, not 76. This is 9. 96.25 millimeter square. So the area of each sector in the silver brooch is of 96.25 millimeter square, and the length of the silver wire that was required to make the brooch is 285 millimeter. Question number 10. An umbrella has 8 ribs which are equally spaced. If you observe an umbrella, the cloth part, what we say, is made by stitching different types of things. That stitching part are 8 in numbers. There are 8 ribs which are equally spaced. Assume an umbrella to be a flat circle of radius 45 centimeter. We are asked to assume that the shape of the umbrella is in the shape of a flat circle. Suppose we are a flat circle. So this is my shape of the umbrella that we are asked to take, and there are 8 ribs. So we can make 8 ribs also. These are the 8 ribs. This is the top part of the umbrella. Rib 1, rib 2, rib 3, 4, 5, 6, 7, 8. There are 8 ribs that are made. That stitching part is 8 in numbers, and each rib is a flat circle with radius 45 centimeters. So we can take a radius is equal to 45 centimeters. We need to find the area between 2 consecutive ribs. We need to find the area between 2 consecutive means one after the other. If you are considering this rib, this will be a consecutive rib, or this can also be consecutive rib. In between 2 consecutive ribs, we get a shape of a sector. If you see, we need to find that area of the sector. The area enclosed between 2 consecutive ribs means the area of one sector. In order to find the area of one sector or the area between 2 consecutive ribs, we need 2 things. One is the radius of the circle that is given to us, and second is the central angle that the arc makes at the center, or the sector has at the center, and that angle is, say, theta. So first of all, we will have to calculate that theta, because the total circle has been divided into 8 equal parts. 8 equal parts, because initially it was told that the umbrella has 8 ribs only. That means 8 equal parts are divided. So very first thing that we will have to do is we have to find a central angle for each consecutive ribs. So we will solve it. Central angle between 2 consecutive ribs. Between 2 consecutive ribs is 360 degree. The total central angle was 360 degree and divided into 8 parts. So this is divided by 8, and this is 45 degrees. So we have got the central angle theta to be 45 degrees. Now we can find the area enclosed between 2 consecutive ribs. Now area enclosed between 2 consecutive ribs, between 2 consecutive ribs is equals to the area of the shape that is formed. The shape is area of the sector, is a sector form, and area of the sector is given by the formula theta by 360 into pi r square. You can take the value of pi to be 3.14 also, 22 by 7 also, as per your need or as you wish, unless and until it is mentioned in the question. So here we have calculated theta to be 45 by 360 into pi, let us take 22 by 7, and the radius is 45. So 45 into 45. The whole answer will be in centimeter square. So this is 45, 8, 7. And 2 4s and 2 11s. No more simplifications. So 11 into 45 into 45, that is the square of 45 is 2025 divided by 4. If you multiply it, 55 by 22, 27 divided by 4, the whole answer will be centimeter square. square. You can calculate it. If you divide it further, you can get in the decimal form. So the area enclosed between the two consecutive ribs for an umbrella is the form of sector formation shape. So area of sector given by the formula theta by 360 into pi r square, and we have obtained the value of theta to be 45 degrees. Question number 13. 11th and 12th number question has been kept for your practice purpose. You can go through your textbook and practice them. Then question number 13. A round table cover has 6 equal designs as shown in the figure. So this is the figure that is given to us. Is a round table cover with 6 designs. Design number 1, 2, 3, 4, 5, 6. There are 6 designs in the round table. And if the radius of the cover is 28 centimeter, the radius of the cover, so let us consider the radius of the cover. This is R is equal to 28 centimeter. Let us name it as O. This has A. Find the cost of making the designs. We need to find the cost of making the designs at the rate of rupees 0.35 per centimeter square. Per centimeter square. That means first of all we need to find the area, total area of the design. Total area of the design is area of this plus area of this plus this plus this plus this. 6 equal designs. So we can find the area of one design, and in order to find the area of 6 designs we can multiply it by 6, and then we can find the cost. In order to find the area of one design, that means the design is in the shape of a segment. We need to get a sector. We need to get a triangle, so that if we subtract the triangle from the sector, we get the segment. So let us draw one more radius. Now let us name it as B. Let us be C. Now here when you observe this, we have a sector OACB. We have a triangle OAB. We have a segment ACB. So in order to find the area of the segment ACB, we have to subtract the area of the sector minus area of the triangle. Then, in order to find the area of the triangle, or in order to find the area of the sector, we need the central angle first, because radius is given to us. Then what is the central angle? Now there are 6 equal designs. If you see 1, 2, 3, if you join this way there are total 6 designs. That means the total central angle, that is 360 degree, has been divided into 6 equal parts. So we can get each central angle for the sector. So let us first of all find out each central angle for the sector. So each central angle is equal to 360 degree divided by 6 equal designs. It was mentioned, so it is divided by 6. So this is 60 degree. Therefore, we can say our theta is 60 degree. Which theta? This theta. That is the central angle for our sector. Let us find the area of one design. Now we can find area of each design. The area of each design is in the shape of a segment. If you need to write segment for your consideration, you can write. Area of each design is equal to area of sector OACB minus area of triangle, and the triangle is OAB. Area of sector is given by the formula theta by 360 into pi r square minus area of triangle. What sort of triangle is it? Again, since theta is equal to 60 degree, and we have discussed earlier also, if this is 60, these two are equal because both are the radius of the circle. By following the angle subproperty, we will also be getting this angle to 60 degree and this angle to 60 degree. So it forms an equilateral triangle. So you can say that area of triangle OAB, what sort of triangle? Equilateral triangle. An area of equilateral triangle is given by the formula root under 3 by 4 side square. So you can say OA square. That is what is the side of that equilateral triangle. And in place of OA, you can also write if you want R square, because A is the radius of the circle. Now substitute the value. This is theta is 60 degrees by 360 into 5. We can take anything we want. 22 by 7 and r square, radius square, that is 28 into 28 minus root 3 1.7. It's mentioned in the question we have to take root 3 is equals to 1.7 by 4 into r square is again 28 into 28. Let us simplify it. This can be taken out 28 into 28, that is 784. So this is 784 is taken out. This cancels 6, then 3. This is 11 by 21 minus 1.7 by 4. So this is 784. LCM is 84. 444 minus 21 into 1.7. Let us calculate it somewhere in the rough one so that 21 into 1.7, 21 into 17, 7, 14 and 21, 7, 5, 35.7. So this is 35.7. Subtract 44 minus 35.7, this is 38.3 and divided by 84, keep as it is. This is 784 into 8.3 divided by 28. So 84. And this can be cancelled. This is 28 3s and this is 28 into 28. So this is 28 and this is 28 3s. So this is as 28 into 8.3 by 3 centimeter square. So this is area of one design or one segment. So we need to find the area of 6 such designs. So area of total area of the design. You can say total area of the design, and that will be 6 into area of each design. So this is 6 into 28 into 8.3 upon 3. Then this is 3 2s, so this is 56 into 8.3 centimeters. This is the total values. Again, let us move on to the further. We need to find the cost of making the design and the rate of rupees 0.35 per centimeter square. So the cost for 1 centimeter square is 0.35, and what is the total cost? So total cost for making the design, total cost for making the design is rupees 0.35 into this was the cost for 1 centimeter square. We have total centimeter squares here this way. This is 56 into 3.3. Multiply all this, we will be getting the final answer. What is the total cost? Let us multiply somewhere so that we can get the exact answer. Let's do it somewhere. This is 56 into 8.3. 18, 1, 16, 48, 4, 14, 44. 8, 4, 6, 4, 464.8 into 0.35. Let us divide it by 35. Moving into this 40, 424, 232, 323, 24, 2, 12, 14, 1, 19, 1, 12, 3. So this is 0, 8, 6, 2, 6, 162.68. This is rupees 162.68 rupees. 162.68 rupees. So the total cost for making the design is 162.68 rupees. Let us do it once again. We have got the area of each design. That area of each design we have got by subtracting the area of the triangle, that to an equilateral triangle from the area of the center, and we have obtained the area as 28 into 8.3 by 3 centimeters square. Then we were moving on to the total designs, because the total designs were 6 in numbers. we have got the area of one design. So total area of the 6 designs we have got is 5.56 into 8.3 centimeters square. And then we found the cost for making it, that was given to us as the cost for making the design was rupees 0.35 per centimeter square. That means the cost was 0.35 for 1 centimeter square, but we had a total area of 56.8.3 centimeter square. So the total cost was 0.35 rupees into the total area that we had calculating. We have got the total cost to be rupees 162.68.